Welcome to another session of Decision Science for Operations Management. That is the sixth session on simulation, chapter 12. We are going to do it exactly the same way we did our simulation case last week. It is going to be the fourth case we are discussing together regarding the simulation, and as I have always told you, the only way to learn simulation after knowing the basics that we discussed all of it mostly in the first two sessions, practice. Just go to your textbook and go to chapter 12, and the questions at the end of the chapter, there are many cases. Just pick one and try to simulate it. And if you face any problems or issues, feel free to contact me. But in the remaining time that we have for the rest of this semester, we are going to do some more cases and discussions together. Today it is case 4, and the problem is what you see in front of you. Very small problem, so we can quickly read it together and know what the challenge is and what is the main question that we are supposed to answer with simulation. Baseball's World Series is a maximum of 7 games. The reason it says it is the maximum of 7 games because, for example, when 4-win happens, okay, that's determining enough to say what team is the winner. When it gets to the 7 game, just I make sure now here refer to, and now we are in the phase of discussing the problem. The first thing that we are discussing is that because it says a maximum of 7 games, why it is not a specified number of games, because it depends on how many times each team win. As I told you, if one team win the first 4 games, okay, the first 4 games, there is no need to continue for the games 5, 6, and 7, because even if in the case the behind team win all the 3 remaining games, still this team is the winner. But if on the 6 games 3 wins for one team and 3 wins for the other team, of course they need to do the 7th one to specify which team is the final winner. So that's the point that I'm sure you are completely familiar, but I found it necessary to discuss it just to make sure you are completely caught up with the points that are discussed in this case. So, baseball's World Series is a maximum of 7 games based on the logic that I just discussed, with the winner being the first team to win 4 games. Assume that the Atlanta Braves and the Minnesota Twins are playing in the World Series, and that the first 2 games are to be played in Atlanta. So we have here the first 2 games, Atlanta. The next 3 games at the Twins ballpark. The next 3 games. And the last 2 games, if necessary, back in Atlanta. So, and also it seems fair the way they distribute the games. 3 for Twins and 4 for Atlanta, while Atlanta's two last home games are scheduled at the last. So you can find it quite fair, at least as fair as possible. If necessary, okay, we talked about this, and taking into account the projected starting pitchers for each game and the home field advantage, the probabilities of Atlanta winning each game are as follows. And as you can see, the home games for Atlanta have higher chance of being won by Atlanta. And here, for example, you see in Atlanta games 60%, 55%, 55 and 50%. But the ones that they are guessed, all of them are below 50%. As I told you, the case that we are doing this week is very small, and it still needs some applying some delicate points of simulation to be able to do it well. But now we are completely know what's happening over there. It is just two teams. They want to play. They would be at least 4 games, and they would be at most 7 games. And the probability of Atlanta winning each game is here. You can find it in this table. And now with this information, we are gonna do some simulation challenges. Okay, the first activity that we are gonna do is this: set up a spreadsheet simulation model. That is the same as doing a simulation. Set up a spreadsheet simulation model for which whether Atlanta wins or loses each game is a random variable. So let's do it in this way. Create a spreadsheet, develop a spreadsheet simulation model, and don't care about the final result. Just simulate the result of each game, because each game is a random variable, my friends. And as you can see in this table, it says the probability of Atlanta winning the first game is 60%. The probability of Atlanta winning the second game is 55%. Now here it asks you to create a spreadsheet simulation model. Of course, it is not the final things that we want here, but it asks you to create a simulation model in which the result of each game is simulated over there. So create such a thing, because I want you to stop the video and doing the simulation model yourself. Get the columns, numbers, and all those things. So you are gonna make something like that. It is game 1, game 2, and like that you go until game 7. I know that not always it is the case that we get to game 7, but it is activity 1 and we want to do some practice together. So game 1, and after that simulate the results if Atlanta win the game or lose the game. It's gonna be something like that. Or you can put, instead of W or loss, you can put 1 as win and 0 as loss. I'm gonna do that simulation, and of course I'm gonna show you the answer for this, but I encourage you to do it first yourself before you check the results in the following parts of the video. Here is the structure I devised for activity 1, because for activity 1 we want to simulate the result of each game separately. So we have one 1,000 cases ready here. As you can see, we go down until 1,000. That's similar to the previous one. And here we have the games, game one, game two, and here is the probability of Atlanta winning. And after that, we start simulating the results of game one. Okay, what is the probability of Atlanta winning the game? 60% is the probability. So I'm gonna model it in this way: equal if rand smaller or equal to 60%, it is 1, otherwise it is 0. See, what I have put here, it says that generate a random number between 0 and 1. If the generated random number is in the range of 0 to 0.6, it is considered as win, otherwise it is lose. Exactly the same way, my friends, we talked about the discrete probability. Now the probability that we have here is very simple. It is just two cases. In the previous one, I guess it was the labor cost. If you remember, we have many different situations. For example, we had 43, 44, 45, 46, and 47. But here we only have two situations. The situation is one of them is win and one of them is loss. The probability of win is 60% and the probability of loss or lose I guess. Sorry for my typos. 40%. So it is that, and so you start exactly the same way we had it before. So we said if it is between 0 and 6, it would be win, and if it is 60 to 1, it would be loss. I guess, yeah. I'm not worried about the wording that I'm using. So it is exactly the same thing that we discussed before. It is not a new topic that we had this type of things. Now I'm gonna also show you, so to remind you everything. So it is exactly the same thing that I have put here. And you see, if random number that we generate, oh, here, smaller than. Okay, here you can see what I was talking about over there. See, a previous situation, we had 43, 44, and like this 1, 2, 3, 4, 5 situation, and they are different cases that we have. But in our new case, we just have win or loss or lose. And okay, so you see, when the probability was 0.1, you started from 0 to this way, and after that the rest goes for this type of things. So I just wanted to remind you that whatever we are discussing here is just repeating what we have learned and practiced together before. It is not something new. So in our case, it would be something like this: win 60% and lose 40%, and we decide about the intervals like this: 0 to 0.6 would be win, and 0.6 to 1 would be loss. And here it is the formula that we are doing it exactly the same as before. If the random number that we have is smaller than 0.6, it would be win, and otherwise it is lose. In fact, in the previous cases, we have done much more complicated cases to get the cases that were nested.